Icaromenippus was the hero of the first science fiction story ever written by Lyceum of Samosata in 150 other Domini. The story was that Icaromenippus traveled to the moon and back. We live in a small island in Greece, Lesvos, here, and that's our town, Mytilene.
Our mission objective. Our primary mission is to measure temperature and pressure and also transmit it to the ground station. Our secondary mission is 3D mapping of Andøya's surface, flight analysis, and GPS location. Our inspiration came from practical applications such as 3D TVs, cinema, video games, and also real 3D mapping satellites missions. Our mission overview. Get and transmit data about temperature, pressure, GPS coordinates, and GPS altitude to the ground station. The microcomponent triggered by a photon will enable the servo mechanism absorbing the cameras of the CanSat. While descending, the two full HD cameras will capture videos of the landscape and save them when entity counts. Each video will be taken by the two cameras, will be framed into pictures, and will be used by two programs, ArcGIS and Autodesk 1-3D CAD, to produce a mesh able to give a 3D models of the surface.
For the external structure of the CanSat, we used carbon fiber, so it will be strong enough to enable us to cut holes in it and don't lose its shape. We use the process of vacuum diffusion, which we made the mold of the whole CanSat cover, put a carbon fiber in it, and infused epoxy resin by a vacuum pump. The internal CanSat structure is built by plexiglass stages and steel screws.
Here's an image of our mechanism. It consists of a servo, two cameras, and some wires. While the cameras can pivot in axis at the base of the mechanism, and when the servo turns 90 degrees, the cameras will open. And now I'm going to demonstrate you live this process. Here's the cameras. When I put my hand over the photocell, the cameras are closed. This happens when the CanSat is inside the rocket. When the CanSat drops from the rocket, light will face the photocell and the cameras will open.
Here we can see the electronics. First of all, the GPS at the top of the CanSat, so it can take a signal from that's. Here's the photocell, which enables the cameras to open. We have two lithium polymer batteries, which is lighter than the common batteries. The two HD 1080p cameras, a mini servo, 9 grams, and down are the sensors, the transmitter, and the Arduino Pro Mini, so that the antenna of the transmitter is at the bottom.
We constructed a ram air Cloud Y airfoil 14-cell parachute, which was made completely from ourselves. We used a lightweight material called ripstop. It's very thin and great for parachutes. We designed, cut it, and sewed all the parts together on our screen. And we use this parachute so that we have a stabilized descent. This will help us because our mission is to take video and we want it to be clear.
In the data analysis process, we are going to take temperature and pressure measurements, and we're going to study them making graphs like that. Also, we are going to calculate the altitude of the CanSat using measurements of temperature and pressure. The 3D mapping is our secondary mission and consists of two parts. The first one is the part that we've already done, which is the creation of the 3D model. Using Photoshop, we took a map given to us by NAROM and we created a better map with 20-meter contours. As you see, the line in the picture consists of points. Every point is a click on the mouse, and I believe it's a difficult way to do the thing. When we finished, our hands were something like that. And after that, we drew the contours in our map and we digitized them. Next, we created elevation zones and we converted that map in a format that can be used to take a 3D image. Using ArcScene, we took that raster file and we gave that three-dimensional form. And then, that's the part that we're going to do here after the flight of the CanSat. We're going to take the photos captured by the cameras and we're going to place them onto the already done 3D model so that we can do a model by our own pictures.
Okay, here we can see a picture of the launch area that gives us by NAROM with a program of competition. We test this picture and put it up to our map model, 3D map model. Let's see a small test about that. And please notice this hill that we can see here. This is our map. The red lines are contours. We will have to draw this. Here is the place that we will launch our CanSat. Also have to have in mind that it's exciting to see that we have worked on in real when airplane come in here. This line is the route of the first team of the first Greek CanSat, which was for our school, and we put this. Here is the area. Here is the picture. Please, this is a hill that you noticed. This one type of 3D, 40 meters hill. Another 3D model that we will produce is connecting photographs. We will use Autodesk 3D CAD 3 photogrammetry program to create a mesh which can produce 3D relief of the large area with a series of frames. And then we will compare the 3D relief with the model, and we will note the deviation from model. Some point to be our mission successfully is, of course, all CanSat systems are functioning properly. Stable descent, we want a stable descent, a good data transmission, and a clear video from our cameras. Moreover, we have to get appropriate for processing counts of photographs, and we will synthesize a 3D map of this area. And finally, we want to understand how we can monitor changes of the Earth's surface from floods, fires, corrosion, crops, flora, greenhouse effects, results, etc.
Thank you very much.
What vertical resolution are you going to get two cameras so close together?
The resolution of the cameras are 1080p, it's high definition. And we're gonna synthesize the two photos from each camera, which will have a 60% overlapping each other. And so we'll make the one type of the 3D model.
What sort of vertical resolution will you get? How accurate is the...
It's really accurate because it's a high definition.
2000. 200 meters.
The cameras will have an angle when they open, so they will have this 60% overlapping.
Can I ask one last question? Did you ask any of your grandmother to make the parachute?
Yes, my grandmother.
Any more questions? No? Okay, thank you very much.
Now I think it's time for lunch, and since there is a limited amount of